Hi guys, and welcome back with another interesting case study today. So today here we have an HP laptop for repair. So you can see this is i3 laptop. So most probably this is a 6th or 7th generation. Okay, so the problem with this laptop, so it is working fine. So if you press the power button, it is turning on, it is booting into Windows, and shortly after booting into Windows, the laptop is shutting down completely. Then we need to disconnect the adapter, then connect it again to turn on the laptop. And after some time, it will again shut down. So this is the problem with this laptop here. Okay, so now look at the ampere reading on the DC power supply and also the voltage reading very carefully. So now the voltage is set to 19.5 volt. Okay, now I'm going to connect the adapter. Yes, so the adapter is connected. So you can see the ampere reading is around 8 milliamps. Checking on the adapter jack, we have white light on the adapter jack, which is the DC jack here. So the white light is there, which confirms that the valid adapter is present, and the EC chip is working fine now because the EC chip is the one that turns on this light here. Okay, so turning on the laptop, opening the laptop, pressing the power button. Yes, you can see now about 600 milliamps, and the laptop executed the display. Okay, so you can see the Windows is loading. Just wait for some time, the laptop will automatically shut down. Okay, so now the voltage reading, look carefully, 19.5 volt. Okay, the voltage reading is the crucial point here in order to solve this case here. Okay, so it is booting into Windows, so it is working fine. Okay, so let me leave it for a while, then you will understand when the laptop shuts down. Okay. So now you can see the laptop has shut down. So what would be the problem? So if you look at the ampere reading, now it's completely zero, not even a 1 milliamp of ampere being drawn by this motherboard here. So it is completely zero. So shutting down of the laptop can be caused due to various reasons like thermal problem. For example, if the temperature on the laptop increases too much, then the laptop will shut down due to thermal trip being pulled low by some components on this motherboard here. And also on some cases, some of the power good signal from some of the regulators may occasionally go low even though the output from the regulator is present. The voltage from the regulator is present. At some times the power good may go low. At that time your laptop will shut down. And on some cases the EC chip may not send the EC on signal to high when the laptop turned on due to some internal fault. So in that case also your laptop may shut down due to 5 volt and 3 volt inductor voltages got absent due to EC on signal was absent there. So there are different types of reasons or the causes that can make the laptop to shut down. However, there will be some clues for us to find where would be the actual fault from the laptop here. In this case also we have a biggest clue, which is if you look at the adapter light on this side here, so it goes off once the laptop shuts down. So if the adapter light goes off, the EC chip is not recognizing it as a valid adapter is present on this laptop here. Or else we can say the EC is not powered right now. That's why it is not turning on this adapter light here. So it can be different reasons. But if I disconnect the adapter and connect it again, you can see we got the adapter light. And if I turn on the laptop after some time like this one, it will automatically shut down. So this is a problem with this laptop here. So our clue is after shutting down we are not getting the adapter light on this point here, and also you can see there's no ampere reading. It is completely zero on the DC power supply. So what I am guessing, when the laptop shuts down, the voltage is not entering into the motherboard. It is just at the DC jack. So the voltage is just at the DC jack. It is not passing even from the first MOSFET to the second MOSFET to the main power rail. So the voltage is only at the DC jack. It is not passing the first and second MOSFET to get the main power rail, because we don't have any ampere reading on the DC power supply. But on rare cases, on some motherboards, you will find the main power rail, but the ampere reading will be still at 000 completely. I don't know what would be the problem with this laptop here. Maybe the main power rail would be present in this laptop. There may be some problem with on some other components. We don't know that. Okay, just a guessing. So now you can see the adapter light on the laptop is going off. So even though the laptop is at standby state, when it is off, the adapter light is going off and the ampere reading is went to 000. So then we can confirm that this is not a problem due to thermal trip on this laptop here. So it can be some other problem on this motherboard here. Okay. So let me disconnect the adapter and connect it again. And we can go for a check on the battery connector here and look at the ampere reading of the DC power supply. And we need to check the voltage when the ampere reading goes 000. Okay, so it is going quickly this time. Okay, so the ampere reading is going 0 quickly. Wait a minute, let me check it. So we have 3.3 volt. The ampere reading is 5 milliamps. Okay, let's wait until it go to 0 and check the voltage on the multimeter. Now the standby IC is generating the LDO voltages because we have 3.3 volt on the battery connector. Okay, up to now it is staying still. Yes, so you can see the ampere reading is now 000. So there is no voltage now on the motherboard, and you can see the LDO voltage went back to 0.6 volt. So it is 0 volt. So the standby IC is not generating 3.3 volt at this time, which confirms that the standby IC is not getting his input voltage in order to produce the 3.3 volt and 5 volt LDO voltage on this motherboard here. Okay, so if 3.3 volt LDO voltage is absent, then the EC chip will shut down. So that's a problem. We are not getting the adapter light on this point here. So as I am guessing, the problem is actually before the main power rail on the first and second MOSFET on this motherboard here. So why does it turning off after it boots into Windows? So what is the connection with that? So we need to think about that. Okay, so now I'm going to do some alteration to the voltage input on this laptop here so that you can get a small clue where would be the problem on this motherboard here, on which section to focus. Okay, so just focus on the voltage on the DC power supply. Now I'm going to increase the voltage little by little and look at the ampere reading also, and also look at the light on the DC jack here. Okay, I'm now going to increase the voltage. Yes, 19.6 volt. No, 19.7 volt. So when you are considering the voltage, we can go up to 24 volt on any laptop. So it is safe to go maximum to 24 volt. You can, just for checking purpose, you can go up to 24 volt, but not above that. Okay, so now we are going to reach up to 23 volt. So under the set limit, we can go up to 23 volt. Okay, 23.3. Yes, so did you see that? At 23.3, now you can see we got the adapter light. So is 23 a normal voltage for any laptop? Actually, no. So basically the voltage for the HP laptop is somewhere around 19.7 volt on original HP adapters. But in this laptop, the EC chip is recognizing 23.3 volt as a valid adapter for this laptop, and it is turning on the adapter light when the voltage is reaching to 23.3 volt, but actually it is not. So there's a problem somewhere on this motherboard here which became faulty, that is recognizing the voltage which is 23.3 as a valid adapter, and any voltage below the 23 volt it is detecting as an invalid adapter and it will not turn on the main power rail. So can you guess where would be the problem on this motherboard here? So which component is responsible for controlling the adapter voltage on this motherboard here? So only when the adapter voltage reaches to 23 volt, some component is detecting as a valid adapter, but it is not actually. So the valid adapter voltage should be somewhere around 19.7 volt. Approximately 19.5 volt is fine, but 23 volt is far more high for this kind of laptop here, any laptop mostly. So let me disassemble the laptop so that we can take out the motherboard and we can start our basic check. We can start from the 19.5 volt input, then we can check a specific component on this motherboard. What is the voltage there when we set to 19.5 volt, and also what is the voltage there when we set to 23 volt on this laptop here. So now you can see the voltage is still and it is not going off, and the adapter light is present, and if I turn on the laptop it will be working fine forever, so there won't be any problem. But most of the adapters come with only 19.7 volt, so operating with 23 volt is fine, so the laptop won't burn itself, or it will be working fine. So up to 24 volt you can operate any laptop, it will be working fine. So however, the set limit is only within 20 volts. That is safe for any kind of laptop. Okay, so now the board is out, so you can see. Now let me connect the adapter. Yes, we have the adapter light. Okay, ampere reading is around 8 milliamps. So let's see whether the light is going off. So my guessing is actually with the charger IC on the adapter detect pin. So you can see the adapter detect pin is there to detect the valid adapter on this laptop here. So there can be under voltage and over voltage protection on this laptop in order to detect a valid adapter. So if the under voltage and over voltage differs on the IC detect pin, then the charger IC will cut off the voltage into the motherboard using the first and second MOSFET. So it will not give the gate voltage for the second and first MOSFET if the adapter voltage is under the over voltage, is under voltage or the over voltage for this laptop here. Okay, so let's wait for some time to see whether this light goes off. So usually I have found problems like it will never switch on the adapter voltage into the laptop if it detects any under voltage or over voltage scenarios on that particular laptop. But in this case it is turning on the voltage into the laptop, and after some time it is turning off the voltage into the laptop. So at that time, so something is happening on this motherboard in order for the charger IC to turn off the adapter voltage into the motherboard here. Okay, right. So let's see what's actually happening on this motherboard. So up to now, I think all the requirement for the charger IC is working fine. Now you can see the voltage is about 19.6 volts, so everything is working fine. There's no problem. But after some time, something is happening inside the charger IC or surrounding the charger IC for the AC detect pin of the charger IC in order to change some reading. So that's why the charger IC is detecting that the adapter voltage is not appropriate and it's going to cut off the voltage into the motherboard. So it will go 000 on the ampere reading when it cuts the voltage into the laptop. Okay. So let's wait for some time to see if this light goes off. And also meanwhile we can check the voltage on the AC detect pin. So you can just look at the ampere reading on the DC power supply. Okay. Right. So this is the resistor that has 19 volt input on this line, and it goes to a resistor divider on this side. So this is the first resistor and the second resistor is on the other side. Okay. So if I check the voltage after 19 volt, this is the 19 volt, and on this side here we have the divided voltage. So now you can see the voltage is not there. The ampere reading is 0. Okay, and the adapter light went off. Okay, so let me disconnect and connect again. Yes, now we got the light here. Let's test it again without touching anything on this motherboard here. Okay. Yes, so you can see the adapter light went off. So we didn't touch anything on this motherboard. Automatically the charger IC cut off the voltage of the adapter into the motherboard, and the ampere reading is completely 0. So no drawings of current from the DC power supply into the motherboard, which means the charger IC has now cut off the voltage into the motherboard. So let me check the voltage on the DC, on the AC detect pin, on the charge, on the resistor here. Okay. Yes, so you can see the voltage is actually 1.1 volt. So typically we should have a voltage greater than 2.4 volt in order for the charger IC like BQ24725 to detect a valid adapter. But on this motherboard we have BQ24780S charger IC on this motherboard, and it is little bit different from BQ24725 but almost same. But anyhow, we should have voltage greater than 2.4 volt on both charger IC. So let me give you more detailed explanation using the data sheet and schematics of this motherboard here. So just pay attention to this one here. Okay, now the voltage is 1.1 volt on the AC detect pin. So now I'm going to disconnect the adapter. Just watch carefully, right? Okay, connecting the adapter. So you can see now the voltage is 2.7, which is above 2.4 volt, above the under voltage threshold voltage. Okay, so the threshold voltage for under voltage is 2.4, and any voltage greater than 2.4 is considered as a valid adapter by the charger IC, and it will turn on the first and second MOSFET to drive the voltage into the motherboard. Okay, right, just watch carefully. After some time this voltage will go to 1.1 volt. At that time the charger IC will cut off voltage into the motherboard. Okay, yes, so you can see now the voltage is somewhere, yeah, it's fluctuating, right? Yeah, 1.1 volt, back to 1.1 volt, and also the adapter light goes off. If I disconnect the adapter, then it will reset it and come back to 2.7 volt. So this fault is not actually with the resistors on the AC detect line, the resistor dividers on the AC detect line. I think the problem is actually with the charger IC here. Okay, so let us confirm that. So this charger IC on this motherboard is BQ24780S. Okay, and on pin number 6 we should have the AC detect voltage, and this is the resistor, which is the R1 resistor. On this side we have 19 volt, and on this side we have the divided voltage, and this goes to the R2 resistor that is connected to the ground. Okay, so I think the problem is only with the charger IC, but we don't need to replace the charger IC only for this problem. We can do some alteration with the resistor here in order to make the charger IC to drive the voltage into the motherboard. Other than that, the charger IC is working fine, because the charger IC is trying to charge the battery as well. So almost it is working fine. So the only problem with this charger IC is that it is pulling the AC detect low occasionally here, okay, up to 1.1 volt. So if voltage of the AC detect goes to 1.1 volt, then the charger IC will not drive the voltage into the motherboard. So let's understand this based on the schematics and the data sheet of this charger IC, and based on that we can make some alteration to the resistor divider here in order for the charger IC to drive the voltage into the motherboard anytime. Okay, right. So first of all, we can just remove this charger IC and check the voltage on the AC detect pin when we set the voltage to 19.5 volt, and just check whether the voltage is stable there. And if it is stable, after removing the charger IC, we can confirm the problem is only with the charger IC here. Okay, so now I have removed the charger IC on this place here, and also I have isolated the current sense resistor on this side. So even though the first and second MOSFET mistakenly drives the voltage into the motherboard, there won't be any voltage on the main power rail, so the motherboard is safe. All the upper MOSFETs are also safe, okay, especially on the charging section. Okay, right. So if we connect the adapter now, there won't be any reading on the ampere of the DC power supply, but we can see a voltage on the AC detect resistor on this point here. Okay, we need to just check the voltage on the AC detect pin, right? Okay, now I'm going to connect the adapter. Look at the ampere reading. Yes, so now I have connected, so there's no ampere reading, and the lights also won't turn on because now the charger IC is not there, and also the CSR is isolated, and there won't be main power rail on this motherboard. So just we can check the voltage on the AC detect pin. Okay, yes, 19 volt, and we have 0.8 volt. Okay, that's interesting. So why do we have 0.8 volt? Then the problem is with the resistor. So actually it is different. We thought the problem is actually with the charger IC. Okay, so the pads are really clean and isolated, no bridges on the pins here. Okay, so let me check it again. Yes, on this point, and we have 3 volt. Okay, you can see we have 3 volts, so there's no problem with the resistor here. So let me check the voltage on this point, but we have 0.8 volt. So why do we have 0.8 volt on this point? So on pin number 6 we have 3 volt, so that is fine. But why do we have 0.8 volt on this pin? I don't understand. Okay, three volt. Okay, so I think these are the resistors actually. 19.2 volt. Okay, 3.0. Yeah, this is the resistor divider. Actually I was wrong, so this is not the resistor. So because we don't have board view for this motherboard, just a guessing. Okay, so I think this is the resistor divider for the AC detect line. Okay, fine. But anyhow, this reading was appropriate because whenever the light goes off, the voltage from this point goes to 1.1 volt. And I don't know what this resistor doing here. And I guess these two are the AC detect resistors. Okay, let me show you that. Okay, on this point we have 19 volt, and on the other side we have 3 volt. Okay, on the other resistor, ground, the resistor that is connected to ground, we have 3.3 volt, and on the other side that is connected to ground, and we have the same voltage on pin number 6, which is the AC detect pin, which is 3.3 volt. Okay, yes, just we can confirm it. Now we have connected the adapter for more than 2 minutes, I think. Yeah, more than 3 minutes, and the voltage is actually stable. There is no fluctuation. So now let me replace the, no, actually let me reinstall the charger IC taken from this motherboard. Okay, and let's see. Okay, so now I have replaced the charger IC that was took from this motherboard back here. So let me test it again. So I have the white light on the DC jack, that is fine. And also the AC detect resistors are this one here. Yes, these two are the AC detect resistors, and this is for some other purpose here, and I was wrong before. So these two are the resistor dividers for AC detect pin. Okay, right, so up to now we can see the ampere reading is 4 milliamps. So we have the main power rate, and also the adapter light is present on this motherboard here. Okay, right, so I have just already tested this motherboard after replacing the charger IC here, and it was working fine for more than 30 minutes and it did not turn off. So actually the problem is only with the dry soldering on the charger IC on this motherboard here. So there's no problem with the resistor divider circuit on the AC detect line. So everything was working fine. So usually if the board did not turn on completely from the start, we can check from the AC detect pin, and the voltage should be greater than 2.4 volt always. So in this motherboard we have 3 volt, so it is okay. So anyhow, I will just use this opportunity to explain you the difference between BQ24725 and also BQ24780 AC detect pin on both of the charger IC and how they work. So in this motherboard we have BQ24780. We can compare it with 725. Okay, so if I press the power button, you can see it will be working fine. Okay, so we need to short one of this pin here to ground. Yes, it has turned on. The ampere reading is 300 milliamps. So we have repaired a motherboard just by resoldering the charger IC on this place here. Okay, so let me wait for like 5 minutes here, so to check and confirm whether if it is working fine. Okay, okay, so left it more than 10 minutes, so it is working fine. So there's no problem with the motherboard right now. So we have just solved this motherboard by resoldering the charger IC here, and everything is working fine. So the board is not shutting down. So let's assemble this inside the laptop and just go for a last check. And now we will focus on the data sheet by comparing both charger IC here on the AC detect pin. Okay, now let's talk about the AC detect signal on both of these charger ICs here. So on this side here we have BQ24725. On the other side here we have BQ24780. So how does the AC detect signal differs between these two charger ICs here? So we are going to discuss that. First we can see about BQ24725. So let me go to the pinout details of this charger IC. Okay, so if you look at pin number 6 here, which is the AC detect signal adapter detection input. So a voltage on this point will be used by the charger IC to detect whether the connected adapter is valid or not. So usually in BQ24725, the voltage on the AC detect signal should be within 2.4 to 3.15. So the voltage should be within this range only for the charger IC to detect it as a valid adapter. So we can program this ACDET signal using a resistor divider here. So program adapter valid input threshold by connecting a resistor divider from the adapter input to the ACDET pin, then to the ground. So we need to use a resistor divider circuit, and we need to use the raw voltage from the adapter then to the ground, and the divided voltage will be given to the ACDET pin here. So if you go to the first page, I think, yeah, on the second page, so you can see this is the resistor divider circuit, and the dividing voltage will be given to the ACDET signal, ACDET pin here, and the raw voltage from the charger directly comes to this resistor divider for the first resistor, and then the voltage will be divided, and you will find a voltage approximately on this point as 2.6 volt. And if we find 2.6 volt on this point, then the charger IC will detect it as a valid adapter. And if the voltage goes below 2.4, then the charger IC will detect it as an invalid adapter. And also if it goes above 3.15 also, on that case also it will detect as an invalid adapter. If the voltage goes below 2.4, it will detect as an under voltage for the laptop here, and also if it goes above 2.4, it detects as an over voltage for the laptop. So on both cases, the charger IC will cut off both of these VIN MOSFETs here. However, if the voltage is within this range from 2.4 to 3.15, it will detect as a valid adapter, and it will turn on these two MOSFETs, and the adapter voltage will pass to the system here. Okay. Further, you can see when ACDET pin is above 0.6 volt and VCC is above under voltage lockout UVLO, RGN LDO is present. So ACDET pin should be above 0.6 volt, and also VCC. VCC means the supply voltage for the charger IC, and it should be above the minimum voltage. That is the under voltage lockout. So it should be above the minimum voltage. When both of these conditions are met, then the charger IC will release the RGN LDO output, approximately around 6 volt. So you can see that is on pin number 16, I think. Yes, so the RGN voltage is approximately 6 volt. And this will be active when the ACDET pin is above 0.6 volt and VCC is above UVLO. So if the RGN is not present, first you need to check whether you have a voltage on the ACDET pin above 0.6 volt. And then if the ACDET pin is above 0.6 volt and VCC is above UVLO, then the AC OK comparator and I out, which means the current output, are both active. So I out means it is just a multiplication or just a multiplier of the voltage drop on the current sense resistor, and this will be shown on the I out pin on pin number 7 here. So the AC OK comparator and I out becomes active. So it doesn't mean it will release the AC OK to high or low, just this comparator becomes active. On pin number 5 here we have the AC OK signal from the charger IC. So if the adapter detected by the charger IC is valid, then it will pull AC OK to high. So it will be high logic, and there will be an external power supply in order to provide a voltage on this point here. And if the adapter detected by the charger IC is not valid, then the AC OK will be low. At this time, you can't provide any voltage at this point because it is at low impedance. So if the charger IC has detected a valid adapter, it will send a high logic on this point, and you will find 3.3 volt on the AC OK signal here. So if you look at the explanation here, AC adapter detection open drain output. So if the adapter is OK, then AC OK will be open drain output. It is pulled high to external pull-up supply rail by external pull-up resistor when voltage on the ACDET pin is between 2.4 to 3.15. So as I explained to you earlier, so you can see the ACDET voltage should be within 2.4 to 3.15, and if it is within this range, AC OK will be open drain output, and external pull-up supply using a external pull-up resistor will provide a voltage at this point, and usually you will find 3.3 volt. And also you need to find voltage on VCC should be above UVLO, and also the VCC on the voltage on VCC pin is above 275 millivolts, greater than the SRN pin. So SRN pin is directly from the battery, from the system battery, and the VCC voltage for the charger IC should be greater than SRN pin, which is 275 millivolt. Okay. So all of these conditions should be met to indicate a valid adapter is present in the motherboard in order to start the charging process. Okay, and if any one of the above conditions are not met, so if any one of the above conditions are not met, then the charger AC will pull low this ACOK by internal MOSFET. So you have an internal MOSFET inside the charger AC, and this will pull low the ACOK signal. So we can understand this from the diagram we saw earlier on the second page. Yes, so here we have the ACOK signal, and this is straightly from the 3.3 volt LDO power supply from the motherboard, and it provides a pull-up voltage. And if the charger AC left ACOK to high logic, open drain output, and you will find 3.3 volt at this point here. Okay, so let me go to another explanation through the internal circuit diagram of this charger IC to understand the undervoltage lockout, then the overvoltage protection, undervoltage protection, and also the open drain output by the charger IC on the ACOK pin. Okay, let me explain that. Yes, so this is the functional block diagram of this charger IC. So here we have different kinds of comparators and gates inside the charger IC in order to switch on and turn on some of its functions inside the charger IC based on the input signal on these pins here. So first of all, if you look at pin number 20, so this is the supply voltage from the adapter for the charger IC here. And if you look at the comparator, so here we have the non-inverting input, and on this point here we have the inverting input, or else we can say this is a positive input and this is a negative input. So according to the working principle of the comparator, if a voltage that is provided on the positive side or on the non-inverting input is greater than the voltage provided on the negative input or the inverting input, you will find a positive, a high logic output on its output side here. And if the voltage is reversed, for example, if you find a voltage on this point as 3.75 volt, but on this point you find 4.5 volt, at this time you can see the inverting input is receiving a greater voltage than the non-inverting input. At this time the comparator will send a low logic at this point here. So basically you need to find a greater voltage at this point here. So if you look at the VCC pin, so this is normally 19.5 volt if the adapter is detected, and sometimes this VCC pin also will be powered using the system battery. At that time you will find around 12.5 volt or sometime 14 volt. So at this point you will find a minimum voltage around 12 volt all the time, either from the battery or from the adapter. If it is from the adapter, you will find 19.5 volt. So if you look at the comparator here, so you have 3.75 volt on the non-inverting input and 12.5 volt on the inverting input, and this is the undervoltage lockout comparator. So if the voltage is greater than 3.75 volt, what will happen? This comparator will output low logic, because you are getting 12.5 volt on the inverting input and 3.75 volt on non-inverting input. At this point the undervoltage lockout function will be disabled because the voltage is now greater than 3.75 volt. And if the voltage is less than 3.75 volt, this comparator will send a high logic at this point here. So if you look at this circle here, so this is a NOT gate. So if you provide low logic, you will get a high logic output after this NOT gate here. So in this case, if we provide 12.5 volt on the input side of the VCC on this comparator, it will send a low logic, and this NOT gate will provide a high logic input to the AND gate here. So the working principle of the AND gate, you need to provide high logic on both inputs to get high logic on the output. If you provide low logic on either input, then you will get low logic on the output side. So now first comparator is now sending high logic on the input side of this AND gate here. And on this side here we have the wake up comparator. If the voltage on the edge detect pin is greater than 0.6 volt as we saw earlier on the pin description, then this comparator will send a high logic on the output side. So you have a high voltage on the non-inverting input and low voltage on the inverting input. So typically you will find 2.6 volt on the edge detect pin here. So this comparator now will send a high logic output. So at the AND gate we are receiving both high logic now, and then the output will be high logic. So you can see the enable RGN signal will be now activated. So this will go to the charger IC. Inside the charger IC for RGN regulator, and it will regulate this voltage approximately 6 volt. It will be there on the pin number 16. So first comparator and the second comparator is working properly, and we are getting high logic on this point here up to now. And if you look at here, we have the ACOVP, which means adapter over voltage protection, and also here we have AC UVP. UVP means under voltage protection, which is this one here. So if the edge detect voltage is greater than 3.15 volt, so let's say you have 3.5 volt at this point, what will happen? This comparator now will send a high logic on this point, because the non-inverting input is higher and the inverting input is lesser than the non-inverting input, and the comparator will send a high logic. And if you look at this point here, also we have a NOT gate, then the input will be low logic. So for the AND gate, if the input is low logic, then you will get a low logic on the output side. If any one of the input is low logic for the AND gate, you will get a low logic output from the AND gate here. And here also we have another AND gate. And here if we have any one of the input is low logic, the output will be low logic. Then it comes to this point, and after 150 milliseconds of delay, then it will go to this NOT gate here. So if you provide a low logic at this point, then the output will be high. If it is high, a voltage will be fed into this internal MOSFET, and this internal MOSFET will switch the ground point to the output side of this ACOK signal. So you will get a zero voltage or low impedance or ground at this point here. Then it will be notified to the EC chip to not to charge, because there's a problem with the voltage detection on the charger IC here. So now let's say we have a voltage around 2.6 volt. So if we have a voltage around 2.6 volt at this point, now the non-inverting input is lesser than the inverting input. Now the comparator will send a low logic at this point. After the NOT gate, you will receive high logic. So one condition or one input is okay for the AND gate to send a high logic output, but we need to get another high logic on this input here. So if you look at this comparator here, this is an under voltage protection comparator. So if the voltage is greater than 2.4 volt at this point, so typically we will find 2.6 volt. So this comparator now will send a high logic at this point. So you will get a high logic at this point. So this comparator, the AND gate, will now send a high logic. So if it is high, and also here also we have another input which is VCC SRN. Yes, so you can see this is the VCC SRN comparator here. So VCC means the supply voltage for the charger IC. So you can see we saw this one also on the pin description before. So the VCC voltage should be greater than SRN, which is the battery voltage, plus 275 millivolt in order for the ACOK to be high. Now let's say if we get 19.5 volt on this point here, now the comparator will send a high logic at this point because the non-inverting input is now greater than the inverting input. So if we get a high logic on this point, we will have the same high logic at this point here. Yes, here. So the both inputs are now high logic and the output also will be high. And after 150 milliseconds delay, you will get a high logic at this point. So this NOT gate will now turn high logic to low logic at this point. Now the internal MOSFET will not switch the ground point to pin number 5 here, and it will leave it as open drain output, and the external pull-up voltage will be provided, and you will find 3.3 volt. So all of these four comparators should work properly in order to get the AC OK signal and also to get the RGN output. Also, if you look at this signal here, which is AC OK drive, and you can see it goes to this place here. So this is a selector logic. If AC OK is high at this point, then this selector logic will drive the AC drive voltage as 24 volt or 25 volt approximately at this point, and this voltage will go to the first and second MOSFET to drive the voltage from the adapter to the system here. So we need to get a high logic at this point in order for the AC drive voltage to be 25 volt. Otherwise you will get just 19 volt at this point here. Then the first and second MOSFET will not switch the adapter voltage into the system or the motherboard here. Okay, so you can see just two voltage, VCC and ACDET voltage, is going inside this charger IC, and it is doing several functions in order to switch on the AC drive voltage to the MOSFET as a gate drive voltage for the MOSFET, and also RGN, enabling the RGN voltage, and also to provide AC OK signal as high. So there are several functions happening inside the charger IC here. Okay, I think now you got it from this explanation of the BQ24725A here. Okay, now let's talk about BQ24780. So almost it is same with BQ24725, just a small difference. So let us compare it here and understand it clearly. Okay. Okay, now let's look at this charger IC here, which is BQ24780, about the ACDET signal and how they are being used on this charger IC here. Okay, let me go to the pinout explanation. Yes, so you can see on pin number 6 here also we have the ACDET signal, which is the adapter detection input. Program adapter valid input threshold by connecting a resistor divider from adapter input to ACDET pin to ground pin. When the ACDET pin is above 0.6 volt and VCC is above UVLO, then RGN LDO is present, AC OK comparator, input current buffer, and all of these can be enabled. Okay, and these can be enabled using the SM bus interface here, which is the I2C, system data and system clock. So we don't need to think much about this one here, just leave it, but we need to focus on this point here. So if you look at this statement, when AC detect is above 2.4 volt and VCC is above SRN but below ACOV, ACOK goes high. So here they have not mentioned the voltage range on the ACDET pin. So the voltage should be just above 2.4 volt on the ACDET pin on this charger IC here. Whereas on the BQ24725, the voltage on the ACDET pin should be within 2.4 volt to 3.15. So if the voltage is greater than 3.15 on 2725 charger IC, then the adapter will not, the charger IC will not send the AC-OK output as high. But on this charger IC, you need to get just greater than 2.4 volt on the ACDET pin. It can be greater than even 3 volt here. If the voltage is greater than 3 volt on the ACDET pin, still it will send a AC-OK output as high. But if you look at this statement, yeah, they are continuing with a comma symbol here. So, and VCC is above SRN but below ACOV. So they are providing a note on this point. So the voltage at the VCC pin should be below ACOV, but not on the AC detect pin. So VCC means the supply voltage for the charger IC should be less than ACOV here. So now let me go to the functional diagram of this charger IC so that we can understand it better. Yes, so you can see we have the same 4 comparators on this charger IC also, but a little bit different, a small difference. So you can see this is the under voltage lookout comparator, that is same, and this one is also same as BQ24725, and the under voltage protection also same. But if you look at the over voltage protection here, they are providing 26 volt on the comparator here, but on the BQ24725 we had 3.15 volt at this point, but this input was connected to this point here. But on this charger IC, this input for this comparator is now connected to the VCC pin of this charger IC here. So the over voltage protection is straightly measured from the VCC pin of this charger IC, but whereas on the BQ24725 the over voltage protection is measured from this point here. So only these are the difference with the BQ24725 and BQ24780 on considering the adapter detection of these charger ICs here. Okay, so if the voltage on this point on the non-inverting input is greater than 26 volt, like around 30 volt, if you find a 30 volt input at this point, then the over voltage protection will be activated. Then you will get 0 volt at this point, and also AC OK drive will be 0 or low logic, and this selector logic will not drive 25 volt at this point. As a result, the first and second MOSFET will not switching the voltage of the adapter to the motherboard here because the over voltage protection is being activated. Okay, so these are the two differences with these charger ICs here. So let me show you a comparison quickly so that you can get an overview of this one. Okay, so if you look at this one, these two are same. So if you compare both of these circuit diagrams, they are almost same except the ACOVP and ACOVP at this point here. So here they are using 3.15 and the input is connected to AC detect pin here, and on this point they are using 26 volt and the input is connected to the VCC pin on the supply pin of this charger IC here. So these are the two differences with BQ24780 and BQ24725 considering the adaptive detection on this charger IC here. Okay, assembled everything inside the laptop. Now let me connect the adapter. So look at the ampere reading. Yes, 20 milliamps. So pressing the power button. Yes, we have the power LED and we got the display. Okay, everything is working fine. So let me leave it for a while and check whether the laptop is turning on without the shutdown. Okay, right, so like 10 minutes or 15 minutes for the last time, we can just check it and finish it off. Okay, so now the laptop is on for more than 10 minutes, so everything is working fine. So there's no problem with this laptop here up to now. So just by resoldering the charger IC, we have now solved this problem. So always the problem can differ according to the different kinds of laptops. Okay, so anyhow, we tried to solve this problem here. So thanks for watching, guys. So stay tuned for our future updates and see you later in a new video. Okay.